Great. Okay. I hope you're doing well. We started a new chapter, and I think I mentioned to you that it's completely different than the last test. All right, and the last test really was kind of one of a kind. This test does concentrate pretty much on chapter 2 and the handout sheet that I gave you. So if you want to go ahead and get that out, did you get one of these? No. Okay. Let me see. I should have an extra one. Everybody else have one of these? So this chapter actually is called measurement, and pretty much if I went to college and I took even a college chemistry class, they have a chapter on measurement. If I took a physics class, they have a chapter on measurement. So all of the sciences that are like a little more math-based sciences, they definitely going to have a chapter on measurement. Now, measurement is going to lead us into all kinds of things. This chart is going to lead us into several skills that you need to know as a science student, okay? If I were teaching Latin, there'd be certain skills I'd want you to know to say, yeah, you took Latin, you have these skills. And it may have to do with verbs, or how do you call them? You call them conjugated. What do you call them in? Is that what you call them? Okay. And so there's certain skills. If you play baseball, there's certain skills that you want to teach. And same thing here, there's certain skills in this chapter that you're going to use all year. All right? That's what we're getting ready to do. And as far as the homework, again, remember you don't have to do on the back of the chapter, you only do the odd questions. But what about odd questions that have like 8 parts to them? How many are you supposed to do? Only 4. And also, there's one whole section which we are not going to be doing here, and that's, remember that, 2.6? And it's actually a really important section. But I'm going to wait and carry it over to the next chapter, which is really small, probably the smallest chapter we ever have. I'm going to put that in there. It's very important, but there's so much else in this chapter. I didn't want to stuff that down your throat with it. So I'm kind of taking that out. That's about the second time I said that, right? Maybe third. All right, well, let's start. And you guys are class, you're E, right? You're called E class. That's you? All right, what do you think? Do you remember, how many of you know your metric powers of 10, your prefixes already? What I asked you on Monday, I said you need to know those like really soon. So really soon is like now. Now, let's say, for example, you don't know them right now. How about that? That means real soon after right now. So let's take a look up here. And let me get this going. I'll help you a little bit on these. All right, so here we have this chart. And this chart is actually full of a lot of good stuff. There's a lot of good stuff here. And we're going to use it to help you understand this chapter. All right, so what we see, and let's see. I'm calling somebody else today. Let's see. This is E. Who did I not call on? I don't know. Madeline, you ready? You can do this. Are you ready? Madeline, how many of these does it take to make one of those? How many of these make one of those? How many of these make one of those? How many of these make one of those? Oh, sorry. How many of these make one of those? Let's try it again. How many of these make one of those? How many of these make one of those? Huh? 10? Okay. How many of these make one of those? Okay. And how many of these make one of those? How many millimeters does it take to make a centimeter? How many millimeters to make a decimeter? How many millimeters to make a meter? Is that right? How many millijoules to make a centijoule? I thought that's good. How many millijoules to make a decijoule? So what you understand is there's a power, there's something there. When they made the metric system based on powers of 10, it's something that you actually know because your number system is based on that too. That was smart. Nobody else had ever made a measurement system like that. Same thing here. Whether I write it like this or whether I write it like that, it's the same thing. All right, Max, you take over. Ready? Max, how many of these does it take to make one of those?
10.
How many of these make one of those?
100.
How many of these to make one of those? And there's 6 powers of 10. How many of these to make one of those? Do you know what 10 to the 6th is?
Million.
Yes. Watch this now. How many of these does it take to make one of those? How many of these does it take to make one of those?
100,000.
How many are there between these? How many are there between these?
100,000.
Yeah, but no, how many powers of 10 are there between? Huh?
Oh, 6.
Yeah. So what's the answer?
1,000,000.
A million. Okay. How many of these does it take to make one of those? How many powers of 10 difference are there? 12, 6, 12, 6. Get it?
6.
How many?
6.
So what's the answer?
Million.
Okay. How many of these does it take to make one of those?
Million.
Yep. Does everybody get that? So even if I look at it in terms of an exponent, if I know that 10 to the third is 1,000, 10 to the 6th is a million, 10 to the 9th a billion, 10 to the 12th is a trillion, right? I don't have to go 10, 100, 1,000, 10,000. I don't have to. I just have to know my powers of 10. All right, other patterns. 10 to the third is 1,000. What's 10 to the minus third? 1,000. 10 to the 6th, a million. 10 to the minus 6 is a millionth. Okay. What would 100,000 be? So, well, 1,000 is 10 to the third. So what's 100,000? 10 to the what? 5th. Everybody get that? All right, let's try it again. How would you represent 1/10 millionth in powers of 10? 1/10 millionth. Well, a million is 10 to the 6th. A millionth is 10 to the minus 6th. So what would a 10 millionth be? 1/10 millionth. What do you think?
10 to the -7.
Yes, 10 to the -7. Am I getting your brain to do things that are maybe a little different? No? You understand how to do this? All right. Now, when they made this, they made these represent powers of 10. So if you know how many of these it takes to make one of those, answer is 10. How many milligrams does it take to make a centigram? 10. How many milligrams to make a decigram? It's 100. See, don't tell me the metric system doesn't make sense because your number system is based on the same idea, isn't it? So there's no way it doesn't make sense. Otherwise, if you can tell me how many dimes it takes to make $1, you tell me how many deciliters it takes to make a liter. Same thing. So it's pretty smart. Now, I don't know your class. There were 2 classes. Did we, besides the prefixes, did we talk about the things on here that are not prefixes? Are you the class that I did talk about microns? Let's do that again, okay? Down here is a story. You can read it. You can read your story. If you see, and by the way, let's review a little bit. If you are a million or bigger, you get to use a capital letter as your abbreviation, right? Other than that, it's going to be a lowercase letter. Now, this is a weird thing. This is called a Greek letter mu. It's a mu, and if you see a mu with a dash after it, it means I'm a prefix, and I mean micro, 1/1,000,000th of whatever you put after me. Microgram, 1/1,000,000th of a gram. Okay, next. But what if you see the mu symbol without a dash after it? Well, the people in the biological world, they were dealing with small things like the size of cells and stuff like that. And they wanted something small, and they had it. It was called a micrometer. A micrometer was 1/1,000,000th of a meter. And it was so small, you could actually, do you guys remember using microscopes? Okay, you can actually buy, it costs about $100, an eyepiece. You take the eyepiece out of your microscope, and you put this one in there. And now when you look in there, you can rotate it. And there's a tiny, tiny little ruler in there, like a really nice ruler. And so if you had a cell there, you could rotate it and line it up and say, wow, that cell is 80 micrometers long. You could actually measure the length and width of things. Somebody do that. Some people do that. I don't know if you want that to be your job, but Some people measure really tiny things under a microscope. All right, now, I don't know the exact story, but I know micrometers takes a long time to say. When they were typing it out, it's a long word, micrometers. And they decided to say, let's not call it a micrometer anymore. If you're a biologist, we're going to call it a micron. So, one more time. If you see this with a dash after it, it means the prefix micro. But if you see that and nothing after it, it means I am 1 micrometer. I am a micrometer. I'm also known as a micron. So, all right, that's one story. And then the people who were trying to measure things much smaller than cells, they were measuring atoms and the distance between atoms, things like that. Nanometers are okay, except, maybe the size of an atom would then be 0.1 nanometers or 0.05 nanometers or something like that. And they decided, let's just make one in the ballpark. Let's make one that's smaller than a nanometer. But this right here, the word angstrom, is not a prefix. It only means one thing. It means 10 to the minus 10 meters. 10 to the minus 10 meters. That's all it is. You okay with that? Every good science student, if you go to college, you're in science, you're going to see micron, you're going to see angstrom. You say, I know what that is. I know what those are. All right, so this is not a quiz. Let's flip it over. Let's pretend it is a quiz. Let's pretend. Now, I had trouble getting these all on here, so what I'm going to do is I'm going to go way up here and put another one, say, what's that say, 6, 7, 8. Wow, I ran out of 9 here. Let's make this 10 to the 9th right here. And let's do a 10 to the 12th here. Then we'll go down here. Got chopped off a little bit. 10 to the minus 9, 10 to the minus 10. Let's go away. 10 to the minus 12 here. Okay, now, let's pretend this is a quiz. And sometimes when I pretend that something's a quiz on one day, the next day it is a quiz. Okay, so let's try it without looking. Without looking, I know you didn't study. I want you to try to fill this chart out. I want you to put I'll do one for you, okay? I happen to know that 10 to the 3rd means 1,000, which is, the prefix is kilo, and the abbreviation is little k. There, I did that one for you. All right, without looking, see how many of these you can do, and then when you think that's it, that's all I can do, then go back and see the ones you didn't remember, okay? So let's try it. How many of these can you put down?
Wait, what did you say to go to on the left?
Oh, on the left, it got chopped off here. I definitely want 10 to the 9th, and I also want a 10 to the 12th here. Now, if I were to give you a quiz, I'd make these smaller, and I'd make sure they all fit on the same piece of paper, but it's just like a practice quiz. How many of these do you know? How many do you know? 1, 2, 3, 5? Okay. Put down as many as you can. And then see if you remember the the prefix and abbreviation. Maybe you remember a story I was telling or a little memory trick. When you think that's as many as I can remember, then flip the paper over and fill in the ones that you did not remember. You say, oh yeah, I remember. No, I didn't remember that one. Try to fill in the ones that you did not know. You can close that. So you want to be a little serious about this. When I said you're supposed to know these pretty soon, I would say by tomorrow for sure. I could see maybe forgetting Pico. That's a hard one to remember. Let's see. No, maybe mixed up Deci and Deca. Maybe mix those up a little bit. Did you remember nano -9? 10 to the -9? All right, let's be honest. Everybody be honest. What do you think about how many you had these? How many, what do you think? You got these down? Okay, can you get it down, you think? Okay, we're going to use these next 15 minutes, so you'll get some of them down just from us using them. All right, let's stop what you're doing. I have two things I'd like to do today. This is all review so far, but the two things I really like to cover today are how do you change one metric unit into another? And it's called metric to metric conversion. And the other thing I want to touch on is scientific notation. Okay, so that's what I'm going to do today. So what I'm going to do is, this right here, even though it's an actual piece of paper, I call it stair step. The stair step method is when you want to convert one metric unit into another. And that's the only thing it works for. It has to be based on powers of 10. So it's called the stair step method for metric to metric conversion. Now I'm going to show you how it works. Now, some of you, you don't have to raise your hand, but some of you probably don't like the metric system, and it's weird because it is easy. Now, you don't think it's easy because they didn't give it to you for, the first 10 years of your life? If you haven't had it in the first 10, what about, that's why it's not easy. If they give it to you until you're a fifth grader, like in other countries, you'd have it. You'd have it by third grade, probably. So I'm going to show you how to make, look at this problem here. 1,042,000 millimeters equals how many kilometers? You said, there's no way I can do that problem. Well, there is. You don't think you can do it because you're thinking in your terms of yours. What if it said 1,042,000 inches equals how many miles? That would be a hard problem. This is not. This is an easy problem. I'm going to show you how to work this, right? When you do this, you start and you look at the prefix of the given. Now, it was given here, so I'm looking at milli, and I'm going to go to kilo. So watch what I do here. Milli is down here, isn't it? Isn't that milli? Now watch how easy this is. I'm going to put my finger right there on milli, and I got to take a trip and go to kilo. I went 1 to the left, 2, I went 3, I went 4, I went 5, I went 6. Now I'm going to write down that my finger moves 6 to the left. Got it? If my finger moves 6 to the left, all I have to do is move the decimal 6 to the left, and I'm done. Now, some of you, I know you're growing up. That's fine. Some of you are saying, I don't see a decimal. Right. If I give you $1,042,000, you think you can find a decimal? I think you can. Don't tell me there's no decimal there. It's there, isn't it? So we're going to take the decimal, and we're going to move it 6 to the left. You go 1, 2, 3, 4, 5, 6, 1.042. You're saying, there's no way it can be that easy. It is. It is that easy. Now, that's not going to happen in your system. Your system was not designed to be based on powers of 10. You can't take inches and feet or miles. It's not based on powers of 10. That's why you don't believe it can be that easy. It is easy. All right, let's do the next one. This one's that's a little bit harder. Try that. Let's see. Let's have somebody, Caroline, read number 2. Read it to me.
880 micrometers.
Or microns.
Microns equals
equals how many? No, not yet.
Nanometers.
Nanometers. Okay, so where am I going to start, Caroline?
At 10 to the -9.
No. You have to start what's given.
Oh, sorry.
Where are you going to find microns? The good news, the micron is found in the same place that micro is. Micro is here, right? The micron is also here. Okay, so micron is a micrometer, and we're going to nano. Tell me what, how many steps in what direction, Caroline?
3 to the right.
1, 2, 3. She knew that nano was 10 to the -9. So he said, I saw my finger go 1, 2, 3 to the right. Now I'm going to write that down, and all I need to do is move the decimal 3 to the right. Now here's your original number, 880. Move the decimal 3 to the right. 1, 2, 3. If you had 880 microns, that would be 880,000 nanometers. Now, is this easy? What do you think? Let's try the next one. We're going to call it Tyler. Ready? You're way back there, Tyler. Where am I starting from?
Right.
10 to the what? Is that deca or deci?
That's C.
Which one?
That's C.
Right? So deci's 1/10, right? So we're going to start here at deci. Where are you going? Not milli. That's a funny looking M. All right, so we're going from deci to micro. All right, let's try it. Deci, how many steps in what direction? All right, 1, 2, 3, 4, 5. I saw my finger take 5 steps to the right. All I have to do is move the decimal 5 steps to the right. Here's my original number, 0.024. 1, 2, 3, 4, 5. Answer, 2,400. What do you think? All right, what I'd like you to do, by the way, number 5 got blotted out, so let's make up a number, 680. Here we go. 680 angstroms equals how many microns? There, we can do that one. All right, let's try, I'd like you to finish 4 and 5. Everybody do 4 and 5, and then do it by yourself. See what you get. And then we'll compare answers. Yes.
What does the L stand for?
Okay, good question. Good student. Let's go over here. Now, wait, let's not go here. Let's go here. Now, do you see where 10 to the 0 is? Everybody see where 10 to the 0 is?
Yeah.
Now that means it's going to be an object that has no prefix. I'll give you an example. M, meter. L, liter. G, gram. J, joules. Snickers. I like Snickers. Now, so if you're an object that does not have a prefix, you're at 10 to the 0. Great question. Great question. So you're going from no prefix to, I got that? Everybody have the first 2 done? All right, Elizabeth Jones. I don't call on you enough. Did you have a good game yesterday? Okay, good. All right, Elizabeth, tell me where I'm going from and where I'm going to.
You're going from 10 to the 0, and then you're going to go
10 to the 0, no prefix.
You're going to go to 10 to the -3.
To the what?
-3.
Right. And how many steps in what direction?
3 to the right.
So what's your final answer?
700.
Was that easy? Has it ever been easy for you before this? Is it easy now? I'm using the tool called powers of 10 to show you that the metric system is the same thing. All right, who did I call on? Noah. Noah, what do you think? What am I going to do on this one? Where am I going from what to what? I can't hear you.
-10.
10 to the negative 10.
10 to -10 to -6.
All right, how many steps in what direction?
It's 4 to the left.
Okay, so 4 to the left. What's your final answer then?
0.0680.
Nice. What do you think? See, a lot of you just don't believe that you're getting these right because it's just too easy, isn't it? Now, you know, eventually this chart is going to be here. Did everybody get that? Eventually, this is something that is up here. Here's another thing eventually you'll be able to do. Angstrom, 10 to the minus 10. Micron, 10 to the minus 6. 10, 6. 10, 6. 4 to the left. See that? Eventually, you won't need this chart. One more time. Angstrom, 10 to the minus 10. Micron, 10 to the minus 6. 10, 6. It's 4 to the left, isn't it? So eventually, that's what I'd like you to do. Not today, necessarily. Not today. All right, let's do the next two. Let's do the next two, and I'll call in some people, and they'll tell me how to do it. You're doing very well right now. All right, Kayla, it's your turn. Now you're way back there, so you got to speak up. Where am I going from? What power of 10 am I going from, and where am I going to? What power of 10 is that?
6
A little bit louder.
10 to the 6 to 10 to the 9.
All right, so mega millions, right? So you're going from 10 to the 6 and going to 10 to the 9th. How many steps in what direction? 3 to the left. What's your final answer? Has this been easy for you before this? You already knew how to do this before that? That's good. Okay, that's good. All right, Danielle, next one.
You go from million to, you go from 10 to the negative 3 to 10 to the 0.
Yeah, no prefix is 10 to 0.
So that'd be 3 to the left.
Okay.
And that'd be 3 million.
Now, so where's the decimal though? If I gave you $3,000, where would the decimal be? 3. Yeah. So the number 3,000 does have a decimal. It's right there, isn't it? So you have to move it 3 to the left. Answer is 3. Okay, let's do 2 more. Let's do 2 more. Then we'll do 2 hard ones. All right, Ty. Number 9. Tell me where I'm going from and where am I going to?
You're going from hecto to milli.
And what power 10s are those?
5.
Hectos is 10 to the 5?
Oh, no, sorry. 10 to the 2nd.
10 to the what?
Second,
Yeah, hecto 100. 10 to the second, where are you going?
10 to the negative third,
How many is that?
5,
Which way?
right,
Okay. 5 to the right. What's your final answer?
1,600,000.
Very good. Very good. All right. Let's see who I'm calling. Caroline Fox. You do the next one. Where are you going from?
You're in from milli,
And what power 10 is that?
negative, 10 to the negative
Yes.
to 10 to the 0, so like 1.
No, you're doing this one, right? So you're going from millimeters to what?
1.
To what?
To 1.
Yeah, that's meters, right? So no prefix, that's 10 to the 0. Okay, so how many steps, what direction? Which way?
Left.
What's your final answer?
It's 1.
Very good. All right. Next two a little more difficult. All right, these will be the hardest ones I've given you all day. Let's do the next two. Let's see who can I call on. Let's see, I don't call on that person. All right, I got my two. Yes.
What is the,
Oh, right here, it got a hole punch in it. It's supposed to be centimeters. So, so number 11 and 12, those are probably the hardest ones. 1 billion micromoles equals how many millimoles? You don't even have to know what a mole is, do you? We'll be saying that word a lot, Madeline. Sorry. But in chemistry, we'll say that word a lot. So that'd be all right. All right, Davis, what do you got? What are you going to do with this? This is different than the rest of them. What are you going to do?
Go from micro to
What power 10 is that?
10 to the -6, -30.
And how many steps in what direction?
It's 3 steps to the left.
3 left? Okay, 3 to the left, right? So here, you start with the N, and you go 1, 2, 3. No, that won't work. What do you do? Davis, what do you do with this one?
I cut off 3 to 0.
So you could write the number 1 billion out. Is that correct? That's a million. That's a billion. So I could replace that with the number 1 billion, right? And then the stair step says, you want to make this conversion? You got to move the decimal 3 to the left. And you're right. That's like cutting off 3. What's your answer then?
1 million millimoles.
Right. And I'm going to write million as 10 to the 6th because everybody knows that 10 to the 6th is a million. All right. And the last one I'm saved for Jonathan. What do you got, Jonathan? A little bit louder.
Just going from 10 to the third to 10 to the -2. It would just be 3.5 million.
What's your final answer?
3.5 million.
All right, how many people had that? 3.5 million. Uh-oh. Jonathan, I don't like your answer. Who has something else? Raise your hand. Oh, what do you have?
I have 350,000.
350,000. Who had that? You had that? You had that? You had that? You had that. Who has something else? All right, everybody's missed it so far. What?
I said it wasn't possible.
That's right. You can't do this one. Da, 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 da. Can't do this one. Now, even though I'd ask you to pay attention to the prefixes, can you change grams into centimeters? It'd be like saying 55 pounds of hamburger equals how many inches? You say, that's stupid. So that was a trick question, right? All right, little trick question. Did you get the MC Hammer? All right, what do you think about that? Pretty easy? Yes? You guys afraid to say anything? All right, I'm going to go to another part, and I'm going to do this next tool. Besides metric to metric conversion, I'd like to show you something that is taught, and I need you to be honest with me, very honest with me. I need you to tell me, have you ever had a math teacher that would teach, or science teacher, that taught you this, how to write numbers in scientific notation? This is very important that I know whether they have or not. Raise your hand if you know somebody taught you scientific notation. Okay, you have had it. You're the only person in the whole room. Okay, now if everybody had raised their hand, I would have had to do something else, but okay. You're probably going to have a math teacher do this sometime this year. It's very possible, okay? If you look at your book, the way the book teaches this is the way your math teacher is going to teach it. Now, I'm not going to teach it either one of those. I am not going to teach it the way the math teacher teaches it. I'm not going to teach it to you the way your book does. You say, what's the matter with you? What's the matter with you? Who do you think you are? Well, I'm somebody who's done this for a long, long time, and I wish somebody would have made me do it this way. So here's what happens. First of all, scientific notation is when you have these really, really big numbers in science, nobody wants to write those out. And if you have little tiny numbers like 0.0000555, nobody likes to write those out. As a matter of fact, who wants to take the time to count the zeros and figure out what it is? They don't. But if we write it like this, 6 times 10 to the 12th, I already know what you mean. It's 6 trillion. It makes it so simple. Look, how about this? 3 thousandths. 3 thousandths. And so it's really a very convenient way of writing numbers in science, and it's called scientific notation. Now, what you do is they're going to do something like this in your book. Okay. All right. Here's what they want to do in math class, and here's what they want to do in your science book. They want to say, do you want to put a number into scientific notation? Step 1. Step 2. Step 3. Do you want to take a number out of scientific notation? Step 1. Step 2. Step 3. Okay. Now, on the one page, it tells you how to put into scientific notation. They have these rules. Some of the rules say something about left. If you do this, go left. If you do this, and the other page says, if you do this, go right. Okay, now what happens about rules like that? Now, what I just taught you before, that wasn't like that. My finger moved left, the decimal moves left. There's no way I'm going to mix that up. My finger moved left, I move it left. But when you see in a book or in a math book how to do scientific notation, I understand some of you said, I'm just going to memorize the 6 rules, and I'll be a good student. No, you won't, because you'll forget it within a week, or you'll mix it up. And if you mix it up, you miss them all, don't you? I don't want you to miss them all. So I'm going to show you something, all right? What we're going to do is, the first step is just like the math teacher would do it. They'd say, move the decimal to create a number between 1 and 10, not counting 10. Now, if you just think about money, it's really simple. So I'm going to do step number 1 for all of these. That'll reinforce step number 1. Okay, what about 0.05? Is that between 1 and 10, not counting 10? Nope. How about 0.5? No. 0.5 is not between 1 and 10. So what are you going to do here? That was easy. How about the next one? Where is the only place you can move that decimal to create a number between 1 and 10, not counting 10? $5.05. $8. $1. $1. $2.50. $2.50. $2.50. $5. $5. Everybody gets step 1. What do you think about that? I'm all right with that. Now, what you're going to do is, we want this number to equal that number. Right now, they're not equal, are they? So what happened is, I moved the decimal, and I stole some powers of 10, so I had to pay them back. And so I just say times 10 to the, times 10 to the, times 10 to the. Now, don't worry, I'm going to pay you back. I'm going to pay you back. Just hang on. There you go. I'm going to pay those back to you. Now, here's where I don't do what the math teacher does, okay? Now, what I'm going to do is I want to know how many places did you have, and don't say left or right. Don't do it. How many places did you have to move it to create that number 5? You said 1, 2, 3. I'm going to put a 3 there. Now, I'm going to go over here, and I had to move it 1, 2, 3. Don't worry about left or right. I'll take care of that in a minute. Everybody get that? What about this guy? I had to move the decimal 1, 2, 3, 4 places. Over here, I had to move it 1, 2, 3. Here, I had to move it 6. Am I going too fast? Okay. This one, I had to move it. Oh, I had to move it once? Okay. Here, I had to move it. Oh, twice? Okay. Here, I had to move it 3 times? Oh, okay. Here, I had to move it 1, 2. Here, I had to move it 3. Now, I'm almost done. Okay? Now, I'm doing all 10 of them at the same time, all right? Now, here's what I'm not going to do what the math book does. I'm not going to do what the science books either, right? I just showed you a big chart a while ago, a big chart. And there's no way that you forget that all the big numbers like this, like a million, they had something in common, didn't they? What kind of exponents do they have in common? Yeah. And what about the decimal numbers? What do the decimal numbers have in common? Yeah, see that? That's all I need you to remember. Okay, so let's take a look. What kind of number is that right there? A decimal? Well, then you have to be this. You have to be -3, right? You had your decimal number. Now, watch. Watch. Decimal number. Decimal number. You're not a decimal number. Leave it alone. What about this guy? You're little. Now I am. You're little. Now I'm little. You're big. I'll leave that alone. You're really big. I'll leave that alone. Okay, here. Oh, you're a decimal. 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 Big. Big. I'm done. Can I tell you that if you do it this way, you'll never mess up? I've given this before. I've given tests where I can put 5 of these on a test, and somebody says, no, I read the book, and I'm going to do it like the book did. And I had a math teacher taught me that once, and I'm going to do it like they did. Okay. If you don't forget anything, you'll get them all right, won't you? But what if you switch them around? You'll miss them all. You're not going to miss any this way. All right. Now, watch this right here. Let's try these. Let's try these. I'll do one, and then you're going to do the rest. Give you a clue here. Ready? Watch. What kind of number is that? No, wait. Let's try it. Wait, let's be careful about that. How many of these numbers on here are positive? All of them. So we're not going to say that. What kind of number is that? Big or decimal? He's big. Now watch. I have to move the decimal 3 places, and when you get done, you better have a big number. But which way do you move it? Left or right? I need to memorize that. Oh, you can memorize it, and if you mix it up, you're going to miss it. Try it both ways. Well, baby, move it both ways. One of them will give you a big number. Try it. Try it. Oh, okay. I'll try it. Let's see. Move it 3 this way. 1, 2. No, it's a small number. Okay, do it the other way. 1, 2. Okay, I can do that. What do you think? What's that? What do you think? Does this make sense? You can even check if you want. Look, big number, big number. What if I had to put that number in the scientific notation? I say 1.5 times 10 to the 3rd? Yeah. Oh. How long does it take to check that? Not very long. All right, ready? Let's put people on the spot. Let's put them on the spot. Lacey, I'm ready. What kind of number is this, Lacey? Decimal or big? Here, look at it here. All the big numbers. Whoa, look at those big numbers. 10 to the 6, 10 to the 9, million, billion. What about, that's a millionth, isn't it? What kind of number is this? It's a decimal. All right. And you got to move the decimal 3 places. And you better have a small number when you get done. Well, whatever direction it is, tell me the final answer. When you get done, it's got to be small.
0.0015.
What do you think? Did you have it? Okay. Max, next one. What kind of number you got here?
Decimal.
Here's a decimal.
375.
Is that a decimal number?
Oh, no. it'd be, oh. okay.
Ah, see?
It's a-
See, you're doing that left and right stuff.
Um,
You gotta move it 2 places, and when you get done, it better be a decimal.
point 035.
Are you doing this one? Are you doing this one?
Which one?
I thought you were doing number 3. Oh, wait.
Yeah, point 035.
Oh, what happened to the 7? Are you doing this one? 3.75 times? Okay, so if you move it 2 places, you get 0.075, don't you?
Yes.
Oh, is it-
You weren't saying this one.
Oh, what's it?
was he doing a different one? Okay,
I mean,
okay, let's go, Ethan,
4?
what kind of number is this?
That's a big one.
It's big.
So it's gonna be 375.
Yeah, look at that. You know, some math teachers take all day. They take all day and teach this. But see, I'm using that vehicle. I'm using powers of 10. 10, you already got it. All right. What do I call it? I recall Ty. Tyler. Noah. What kind of number is it, Noah?
big number.
He's big. You're gonna move it 5 places. And you get down, it's gonna be big. 1. Here's a 2.2, right? I'll move it 1. I'll move it 2, 3, 4, 5. What do you think about that? Okay, I'll just do the next one since I did that one for you. What kind of number is this?
Small.
All right, give it to me.
It's gonna be point 335.
Yes. Nice. All right. John, what kind of number is this? Okay. Okay, and if I did it backwards, I'd say 1.2 times 10 to the minus 4th. See? Small number. Everybody is? All right, Madeline.
Say 10,000.
And everybody's supposed to know that 10 to the third is 1,000. What's 10 to the fourth? If 10 to the third is 1,000, what's 10 to the fourth? 10,000. I could have done it that way too, right? Next one. Back to Caroline Kubert. What kind of number is this?
Decimal.
Okay.
0.1.
All right, very good. And next one. I don't know, Lacey.
Just 4.
Right. Anything to the 0 power is 1. 4 times 1 is. There you go. What do you think? Now, I just taught you 2 tools, 2 skills in science, and they both have to do with that chart, don't they? If you know your metric prefixes, you can convert any metric unit that can be converted into any metric unit. And also, the idea of scientific notation should make sense to you. It should make sense. I was not taught this way. I do remember mixing them up. I do remember saying, here's the way the math teacher does, watch. We will move the decimal points so there's only 1 digit left. I did that. And then it says here, where is it? Usually in the book it says something like this. If you move the decimal to the right, it's a negative exponent. If you had to move the decimal to the left, it's a positive exponent. Now, I understand you can memorize that if you want. I'm not going to do that. I might mix that up. I'm not going to mix this up. Decimal number. Not going to happen. What do you think? Okay, I got a couple of minutes here. Let's try. Here's what I want you to do. This is for practice. It's not. You don't have to turn it in. I want you to pick 5 of them that are completely different from each other. Pick any 5 you want. Just make them completely different, and then try them. If you have a partner not too close and pretty close to you, just pick the same ones. Look her in the eye. Look at her. Look at her. Which one do you want to do? Pick one. 4. Okay. What do you want to do? Now your turn.
21.
21. Okay. Now look at her again. What are you gonna do now? 17? Okay, now one more. But let's do 4, Max, one more.
6.
6? Okay, there you go. Now they know which one they're doing. So everybody's going to practice about 4 of these. And look at me, just look right in the eyes. All right? There's not much to look at except the mask, except the eyes. All right, I'm going to stop here.